In this module, we will be discussing electrical circuits and moving further in the knowledge of electricity. We're looking at the basics, looking at the atomic structure and of electricity. So we're discussing the atom structure, looking at conductors, the type of materials made out of, what makes a good conductor, what makes a good insulator. We're going to identify the role of magnetism in electrical devices, and we're going to do identify the basic components in a power distribution center. There's no performance test for this module so far. And the first thing we look at when we're looking at electricity, it's breaking it down to the smallest particle would be an atom. An atom is constructed of a nucleus, which has the proton and a neutron in it. And then on the outside of it, orbiting around the nucleus, would be the electrons. It all depends on the atom, what it's made out of. Some have multiple electrons, some only have one or two, but it depends on the component or the element of what it is. So when we're looking at copper wires and things, one thing all good conductors will have is one or two electrons in its outer shell. We call that the valence shell. Again, here's for electrical to flow. It needs three basic things. You need a power source, and which is we measure it in voltage. It has to have conductors, which is wires connecting to some type of device like a light bulb, and also we call that the load. A load. All loads have some type of resistance, and if you have those three things, a power supply, conductors, and a load, it will allow electricity to flow through it. And here's another thing about loads. Keep this in mind. All loads will consume electrical energy and will do some type of work. When I say work, it is doing something. For example, a light bulb would glow, it would get bright. A motor would turn, a heater would get hot. So, in other words, if it does some type of work and is consuming electricity, it's a load. So, again, we just talked about the atom, and part of the atom would be the nucleus and electron, and inside of the nucleus will be protons and neutrons. There'll be an equal number of protons and neutrons. Again, the protons are positive charge, and the neutrons are it doesn't have a charge. So it has a well, it doesn't have a charge, not positive or negative. It's neutral. And of course, electrons, it has a negative. So we look at this picture here, we can see that, let me just, this here we see the electron. And electron circles around the nucleus at very high speeds. And because of the attractions, it will continue to flow around it very quickly. So again, if it only has one electron in the outer shell, it becomes a conductor. If it's three or more, it becomes a semiconductor or insulator. If you have more than four, it's becoming an insulator. Some things like insulator would be like glass or rubber, ceramic, things that do not conduct electricity. And look at charges, and I kind of mentioned about the protons, the neutrons, and the electrons, is that when you have different charges, it will uh, uh, approach each other. It will try to attract to each other. So in other words, is that negative charges and a positive charge will go to each other, and like charges, when the charges are the same, like two negatives or two positive, they will repel each other. Here's a atom structure, and you see that it has a lot of electrons. And however, the outer valence shell only has one electron. So that would make this this atom, whatever material it is, a very good conductor. Current can flow through it easily. So again, conductors, it need to have few um, electrons in its outer shell to become a good conductor. And the more electrons it has, it becomes less um, of a conductor and become more of an insulator. There are certain things that we call semiconductors because it's not a good conductor or insulator, so it kind of resists the flow of current somewhat, but it still allows some to go through. What magnetism has to do with electricity? Everything. Everything. Without magnetism, we wouldn't have the electricity that we have now. Matter of fact, they call it electromotor force. In other words, when current is flowing, it's causing movement of something, like the electrons, but it generates a magnetic field. Here's the cool thing, is that if we actually have current going through a, um, a wire, a conductor, it will produce a magnetic field around that wire. And it's really interesting, and we can use that magnetism to do work. In other words, inducing that energy of magnetism to be able to cause something else to move. So magnetic fields are used to operate motors, relays, transformers, and solenoids. A magnetic object have a north pole and a south pole. Opposing poles attract while the um, like poles will repel each other, just like electricity. Now, here's one of the greatest things about current flow. If you have current going through a wire, and I said it produces a magnetic field. However, if I actually coil that same wire up, every time I make a loop, 360 degrees loop, it becomes stronger. So in other words, it doubles every time I make a loop. So again, it becomes stronger. So the more turns of a wire, it will produce a very strong magnetic field. And it can be so strong that it can able to lift very heavy things. Um, so if you've ever been to a junkyard and see the guys picking up things with this big giant magnet, basically that was an electromagnet. And the way it works is a big giant coil of wire inside of that uh, mechanism lifting the different things. So they could close a switch, electricity go through that and power up that coil. Coil would be able to lift up things. And as soon as they flip the switch back to the other direction, it will release it. And again, that's how they can control things by using magnetism. Power distribution, it of course it starts out at the power plant where they're producing electricity. They're producing it different ways. They can use some type of another energy source, such as natural gas, coal, electricity. I guess you can use electricity if you have electricity already there present, but usually they use another source, such as coal or natural gas or some other type of fuel to heat up usually water in a boiler to generate steam. And they pressurize that steam to very high pressures and use that steam to to push a turbine. That turbine will spin at high speeds, and that turbine would be through a shaft will be connected to a electric generator, and that generator would turn and produce electricity. And they take that power and send it through power lines, distribution lines. Usually the distribution lines would be at extremely high voltage in the thousands, sometimes tens of thousands of volts. And they would send it up, transforming that power coming from the transformers and boosting it up to higher, send it through the power lines hundreds of miles sometime. And then they will step it down as substations and to the cities where they can drop the power back down to a lower number. And before it gets to the house or business, they would step the voltage down again. Instead of running thousands or tens of thousands of volts that is coming from the power plant, the electrical power at the residential commercial buildings or even industrial buildings will be operating at a lower voltage, safer voltage. So this is showing you the distribution of power to a house. And you can see the power lines coming in. It drops down to a transformer, leaving the transformer, goes to a house, which will only be a low voltage, usually around 240 volts. And they will split that off into 120. So your lights and your outlets will be at 120. Other things that use is higher voltage, such as your air conditioning system, if you got a central air, electric dryers, electric stoves, things like that will use a higher voltage. Okay. Now, on commercial applications, the voltage can be higher. So it can be 208, 230 to 240. It all depends on the neighborhood. And it depends on where it is going. Of course, it can be higher than that. It could be at 480, 460 to 480. And some applications in industrial, you may find 575. In some factories, you may have over 1,000 volts, 1,100. 68 volts is a common voltage that you may find. So again, it would vary based on the application. Some terms we're going to talk about. Amperage is basically the speed of electrons. Atoms is the smallest form. A battery is a direct current voltage source that comes from batteries or having some type of chemical reaction to create the voltage, um, like your car battery. Yes, they would charge it up, but they use lead plates inside of it. You use an acid, and the chemical reaction between the acid and the lead plate, when you charge it, will store electrons on that plate. There's other type of batteries, like the batteries you put in your devices. There's a chemical reaction happening inside of that battery. Okay, a charge is a quantity of electricity that either positive or negative, that's a charge. A circuit is a complete path for current to flow. In the beginning, when I said that electricity to flow, when we were talking about atoms and things, have to have at least three things. You need to have a power source, conductors, and a load. That's a complete circuit. So a complete circuit will allow current to flow from one point to the other point, leaving the power source and then coming back to the power source. And between those 2 points will be a load what consumes that energy. Conductors, again, is the wires. Current is the speed of the electrons. Electrons basically is the negative charge particles that orbit around the nucleus of an atom. Insulators are materials that which is difficult for current to flow through. Matter, anything that occupies space and have weight is called matter. So again, gold is matter, silver is matter, um, silicone is matter, oxygen is matter because it has weight and can occupy space. So, so all matters have its own characteristics of its weight and volume it holds and how current can flow through it. So again, that is matter. A neutron is the electrically neutral particles in the nucleus. And the nucleus is the center of an atom. Ohm is the measurement that we use to measure resistance. Resistance. And resistance is something that will slow down the flow of electrons. Power source. Um, so a proton is the smallest positive charge particle of an atom. And again, the protons are positively charged. A relay is a device. Matter of fact, it's just an electric switch. That's all a relay is. It turns something on and off electrically, and it will have a coil in it. Remember, I said a coil of wire will generate a magnetic field. We can use a coil of wire to pull a plunger in to open and close a switch. So that's all a relay is. It's just an electrically operated switch. Instead of having someone to come up to a switch to turn it on, turn it off, this can automatically turn a device on and off. Resistance is anything that can impede the flow of electrons. So something that will slow the flow of current through a circuit. And we measure resistance in ohms. A solenoid is very similar to a relay. The difference between a relay and a solenoid is a mechanically operated, it does mechanical work, but it has electric action to cause it to open and close. So a solenoid is very similar. It's a valve that will open and close electronically. So you can use electrical current, a magnetic field again, and a coil to pull a plunger to actually stop the flow of a fluid or something, um, and to allow it to flow through. So stop and allow flow through a mechanical device. So a relay will control electrical circuit, turning electrical circuit on and off, but a solenoid will turn some other flow off, like again, a fluid like hydraulics um, or a water valve that's controlled electronically. A transformer is a device that either step up or step down the voltage. So in other words, step up transformer will increase the voltage higher than the input, and a step down transformer will decrease the voltage less than the incoming voltage. A valence shell is the most outer shell of an atom. And of course, when it comes to current flow, anything with a very few electrons in its outer shell becomes a good conductor. A volt is the force that pushes the electrons. And a force is something that allows the pushed electrons to make it flow through a conductor easier. In other words, the higher the voltage, more force you have, more you can push through a wire. The lower the voltage, just the opposite. It will slow down the flow. So we use voltage to allow current to go through wiring. And that's volts. And volts is what we use. Uh, so in other words, if you got 120 volts in a outlet that is there, that is the force. But the voltage is what does the work. The voltage is the electric motor force. It's the potential difference. When I say potential difference, we're talking about the difference between the positive and the negative. Or again, when there's a difference in the sides of the power. And watts is no more than the energy that is consumed. Watts is a measurement of energy. And many times we call energy power. How much power does it have? But all it is measuring the amount of energy. So a watts is basically a combination of the voltage and the current. If you know what the voltage is and what the current is, you multiply those and that will give you the wattage. That's how we measure the amount of energy you're using in the house, by using a watt meter. So outside of every one house, you have a meter out there, and all it is a watt meter. And that's how the power company knows how much to charge you based on how much energy you use, which is read by that watt meter. Couple questions. A proton repels what? As a proton repels electrons, protons, neutrons, or negative ions. It would be the proton. Protons repel protons. Remember, like charges repel and attract. The attraction comes from when it's opposite. Number two said an atom with 7 valence electrons is most likely an what? Remember, if you only have a few, it becomes a good conductor, but if it has a lot, more than four, it becomes a insulator, an insulator. Next question. Current flows through a conductor coil around an iron bar, produces a blank. It becomes an electromagnet. The voltage used by a typical television or toaster is, of course, you find this in a house, and that's the most common voltage we use from receptacles or light circuits, and it would be 120 volts. And this is the end of this section. We're going to get started on the next.